Okay, this video is going to talk about how we can use Ohm's law and Watt's law to find an unknown in two types of circuits. So let's talk about the circuit rules to start with. This is a series circuit. It has one path to ground, so if you haven't opened any place in this, all the lights will go out, kind of like your old Christmas tree lights that we all didn't like. The other rule is the total circuit resistance is the sum of the loads or resistances. And the other is that anytime you check the amperage in a circuit, it's the same throughout the whole circuit. So that's the rules of a series circuit. Now, a parallel circuit is different. Okay? The rule here for voltage is the voltage going through each leg is your source voltage, which of course these are both 12-volt batteries the way I've drawn them. The other one is the total circuit resistance is less than the smallest resistive leg. So we see we have a 6 ohms, 2 ohm, and 4 ohm load or light bulb in here. So we know when you do the calculation on this, our total circuit resistance will be less than 2 ohms. Okay. The other one is the amperage that flows through each leg will equal the total circuit amperage. So let's go ahead and do some math here, okay? So we have our series circuit, and we talked about it's pretty easy stuff here. So what we're going to do, we're going to go ahead and make a determination of the total circuit resistance. All right? So, there again, we know from we just talked about it, we're going to add them up. So 2 and 9 is 11, and 1 is 12. So that this has 12 ohms. Be sure to identify what you just measured. So we have 12 ohms of resistance. Now, of course, our bottom line is here, we want to find out the watts in this circuit. So let's go over and plug in our knowns in our Ohm's law circle. So we know we have 12 volts. Okay, we just determined that we have 12 ohms of resistance. So anything that goes sideways in either the Ohm's law or the Watt's law is multiplication, and anything up and down is division. Now, anytime you use your calculator, you want to put your top number in first. I'll show you how that works. Okay? So, we want to find out the amperage. So we know here we have 12 volts, and we divide that by 12 ohms, so we have 1 amp flowing through this circuit. So I'm going to go ahead and identify that as an amp. Now we want watts. So let's go over to our Watt's law triangle here and plug in what we know. Well, we know we have 1 amp and we have 12 volts. So 12 times 1, so we have 12 watts on this circuit. And there again, we're going to go ahead and identify it. Pretty easy stuff, guys, right? So if I can make a fairly complicated circuit a series circuit, we can almost do it in our sleep. So let's go here and let's get rid of some unknowns that we don't know at the moment. So we know we're going to end up with 12 volts, of course, so we'll get rid of our watts. We don't know how many ohms we're going to have. We don't know how many amps we're going to have. So we'll just leave our known values in there. Okay, so as we just talked about, let me go ahead and erase this so it gives us a little more working room here. Okay, the first thing we want to find out is our total circuit resistance. And on this one, we know it's less than 2, so we need to use a formula. Let's call this leg 1, let's call this leg 2. So what we're going to, the formula is the resistance of leg 1 times the resistance of leg 2 over the resistance of leg 1 plus the resistance of leg 2. And we're going to do the math. We'll multiply this, put the figure here, add this, put the figure here, clear our calculator, and put this number in first, hit divided by, and this number. And what we're really doing here, we're going to eliminate these two legs, and whatever the distance between those two is, will become this one. We'll get rid of those. And we still have a parallel circuit, so we're going to do that one more time until we have a series circuit. And we've already done that, and it's pretty easy there. So let's go ahead and do our math. I'll get rid of the formula here. So we're going to have 6 times 2 over 6 plus 2. So we have 12 over 8. Now if we go ahead and do the math here, we're going to realize that that is 1.5 ohms. So let me put this, 1.5 ohms. Now, we just got rid of this leg, right? And we got rid of this leg. So we still have a parallel circuit here that has two legs. So let's go ahead and do the math again. We're going to get rid of this leg and this leg, and we're going to end up with one load here. So what we have here, 1.5 times 4 over 1.5 plus 4. So this is 5.5 over 6. So we clear our calculator, we put 6 in, hit divided by 5.5, and we're going to end up with 1.09 ohms. So we just got rid of this leg, and we got rid of this leg. Wow, look at that. What kind of a circuit do we have? A series circuit. We just did that. It was pretty easy. So let's go ahead and answer some questions here. Our total circuit resistance, we know now, is 1.09 ohms. Okay? We knew it was less than 2, so we proved the rule. Okay, the next thing they want is the amperage. So let's come over here. We had 1.09 ohms. So we go ahead and we're going to divide the 1.09 into 12 to find our amperage. Because the bottom line is here we want to find out what the watts, the power consumed by that circuit. So we have 1.09 divided by 12, and that is going to be 11 amps. We have 11 amps flowing through here. Let's go ahead and identify it. Okay. Now, bottom line is we want to find out watts. So let me go ahead and put our amperage in here. We have 11 amps. So now we're going to multiply 12 times 11, which is going to be 132 watts. You might ask yourself, why do I need this? How's this going to help me fix a car? Well, think about this. You put a lot of the people at college here are Jeep guys. You want to put a light bar on the top of your Jeep so you can see better at night. So you buy it and it shows this is a 100-watt light bar. So you need to go ahead and install it and wire it up. But very important is you want to put the proper fuse in to protect the circuit. So you're going to use Ohm's law, Watt's law together to determine how many amperage the fuse is. Okay, I hope that clears everything up. The bottom line is we know that a series circuit is easy to work with, so we're just going to use this formula until we knock out every leg in it until we only have one leg, and then of course we have a series circuit and it's easy money there. Thank you. How you doing?